What I notice is that my rates are in kilometers per hour. My distance is in kilometers, so my time has to be in hours. That's the first thing right away, make that hours. So we have the total time. We don't have the time for each segment, but that's what we're trying to figure out. The time for each of these parts of the trip itself. So maybe, you know what? It says the beginning one is 80, the second one is 100. Maybe it's right here that the changeover happens. Or maybe it's right here that the changeover happens. Do we know anything about the individual distances? No, right? Nothing at all. Okay. So when I look at a problem like this, I ask myself, okay, what information can I use from the entire thing? Well, I could say, let's call that first x the first spot that we're looking at. So if I call this d1, then what's the distance on the other side equal to in terms of d1? In terms of d1?
260 minus d1.
Yeah. Are we agreed? Does that make sense so far? If I go 50 miles, how much is left? Well, take away 50 miles from the 260 that I'm going. So I don't know what d1 is. It might be 50 miles. And then this would just be 210. 50 and 210 is 260. So I start right away with using variables to designate the different portions. Then I look at the problem and ask myself, what formula can I use that involves distance and rates? So what's the governing formula for distance and rates? What's the one that we've used all year? What do you got?
Distance equals rate times time.
Yeah. It's a formula you learn like in your middle school math classes when you start learning about rates of change. So in this problem, I want to utilize that formula somehow. Now, I don't have the time in the beginning. I don't have the time in the second leg. But I know the total time at least is 2.5 hours. I know the total time is 2.5 hours. I know the total distance was 260 kilometers. So if I call this first time t1, what would the second time be? The first time we called t1. What would the second time be in terms of the total time?
2.5 minus t1.
Yeah? So take a look at it again, make sense of it. The total time is 2.5 hours. If the first leg of the trip were 1 hour, I would take away the 1 hour from the 2.5 hours that it took me for the entire trip. So I at least know certain things at this point in terms of other variables. Now, sometimes, I don't think this is one of those problems, but sometimes your textbook gives you some problems where there's not enough information to solve. It'll state that there isn't enough information. I don't think this is one of those circumstances. So let's think about what formula would work here in this case. So I could start with the beginning of the problem and say to myself, well, I could use d equals rt for the first leg of the trip, and that'll be d1 equals 80 times t1. All right, that's the first leg of the trip. This distance, we called it d1. This time, we called it t1. So those go in place for d and t. And the rate of change here was 80. The rate of change was 80. So that works to start. Second leg of the trip, what would that state? What would the formula from the second leg of the trip be? And don't use d2. Use what we have written on the diagram. Go ahead. How's that?
260 minus d1
Good.
equals 100 times 2.5 minus t1.
Good. Times the quantity 2.5 minus t1. And think about this. The second leg of the trip, the distance here that's left over is exactly what we wrote in red here. 260 in black here. 260 minus d1. That's what distance is left over for the second leg of the trip. We know the rate at which we're traveling in the second leg of the trip. This is the total time minus the time from the first leg of the trip, which gives us the time in the second leg of the trip. So when I look at this, I notice, how many equations do I have? How many equations?
2.
How many variables?
2.
So can I solve?
Yeah.
What am I solving then? What do we call this? 2 equations, 2 unknowns. What do we call it? System of equations. So either, what method may I use?
Substitution.
Yeah, or?
Addition, subtraction.
Good. Substitution or elimination. Either one. Now, If I'm looking at this problem, I would absolutely use substitution. It doesn't make sense to deal with elimination here, right? Is everybody clear to see why that is? It only makes sense to use elimination when you have coefficients for all your variables and they all line up and you can add straight down and cancel x and y and whatever it is. But here we don't have that. So I would personally think about what am I being asked for in this problem? So go back to John. John, what is the problem actually asking us for?
Find the distance he traveled at 800 kilometers per hour if his total driving time was 2 hours and 30 minutes.
So we are looking for D1. Find the distance traveled when he's traveling at 80 kilometers per hour. That's what we're trying to find, this distance, D1. So think logically, people. If I go ahead and say, oh, D1 is 80 T1, I can just take this and plug it in here. It seems like that would be nice and easy, right? But what does that do to this equation? It eliminates D1. Think about it logically. If you took 80 T1, right, and plugged it in here, now you've got a T1 here, a T1 here. You could solve for T1, go back and plug it in for T1 to get D1. So that is one way to do it, but it's an extra step to plug in at the end. So instead of isolating D1 and plugging it in here, what might you do instead? What might you do instead? What do you think?
Isolate T1.
Yeah. Whatever variable you want to eliminate, isolate it. So if I want to get rid of D1 completely, I could do that right now by taking this expression, 80T1, and plugging it in right there. And D1 is gone. But I don't want to get rid of D1. I want distance in the first leg of the trip. That's what we're trying to solve for. So solve this first equation for T1 instead. And then plug that expression in right there for T1. Now, yeah, it's going to be a fraction. I get it. But at this point in the year, we should be kind of better at doing fractions here, right? Shouldn't be as much of an issue as earlier in the year we might have said, like, oh, I just don't want to deal with fractions. So this equation becomes 260 minus D1 equals 100, parentheses, 2.5 minus D1 over 80. Now, how do I go about solving this? I could do it several different ways. I can first distribute the 100 if I wanted to. Right, that works. If it makes it easier for you, that's fine. You can do that as well. The 180 would cancel the 10 over 8, which would give us 5/4 as a fraction, still having a fraction in there. Or I can just multiply everything by what to clear out my fraction? What can I multiply everything by in this case? Yeah, 80. Multiply by 80 here, makes this 80 times more, puts an 80 there. Multiply this side by 80. Now, here's the thing. This is where it gets a little funky. When you multiply the right side by 80, I think of putting 80 over here, and then distribute the 80 to both of these. Don't multiply it by 100. It wouldn't make sense to put the 80 here, and then redistribute that after. The goal is to get rid of that 80 in the bottom to make it easier on us. So I would go ahead and put an 80 on both sides, like this, and this. This 80 gets distributed to both of these. It's 8 times 26, give us. Nobody?
I think it's 208.
Yeah. I think you also looked at a calculator there.
I
Two.
didn't.
Oh, okay. I just saw you going like this. That's why. I'm like, you looked up with that weird look. 20800. Where's the 00 come from at the end? The two zeros from 80 and 260. Whatever. Quick mental math. But to your benefit, you'll have a calculator on the whole test, so you don't have to worry about that stuff. 100. Now, notice, I don't change the 100. Leave it alone. Distribute the 80 to 2.5. That becomes 200. 80 times 2.5 is 200. 80 times D1 over 80, the 80's cancel. That's the whole reason we're multiplying by 80. And now that's a lot easier to solve. Either way, honestly, it wasn't that hard to solve. You could have distributed 100 and just gotten a bunch of decimals and done all the work because you can have a calculator. Can I leave it at this point for us to solve on our own, right? If you need to continue this. Distribute the 100, collect your D terms. You're going to have like terms here and here. This will be 100 in front of it. Collect them, move the constants over, solve for D1. Okay? Good really good question. Perfect example for an exam type question. Perfect example for an exam type. If you can handle this, you'll be fine for distance rate problems.
When I was doing this, I got a negative answer, and I still don't see like how you get a positive answer.
let's see. This is going to be a negative 100 over here, right? Negative 100d. When I add that over, it makes it a positive 20d over here. This is going to be 200 times 100, which would be 20,000. 200 times 100, 20,000. 20,000 minus 20,800. You're right, that is going to be negative.
Yeah.
What did the back of the book say as an answer? Is it possible that this physically isn't possible for it to happen? Because remember, some of the problems in this topic said, if the solution is not possible, state so. So if you were to get a negative answer for D1, it's definitely not reasonable. Something's either wrong in the problem or wrong in what was given. But the arrangement of this problem is definitely right. What do you end up getting? It's page 53, number 15.
No solution.
There you go. So the fact that you got D1 equals a negative number is indicative of the fact that there is no real solution to this answer. It's not possible for this trip to happen at these rates and for you to have it happen in only 2.5 hours with these given distances. Okay? Good question. I'm glad you asked that because that is an issue. I don't plan on making your test like if the problem isn't possible, state so. They'll be solvable. Unless it's like where you check an answer and it's an extraneous solution. You have to reject that solution. Okay? All right. Next. What else do we? Yeah, good.
It was a problem with S.
Okay.
It was square root of x squared plus 6x plus 9.
And it said simplify, right?
Yeah.
So when I want to simplify a problem like this, first of all, when it says simplify, be careful. Some of you did this and you saw this and you did like find the values of x that make this a real problem or a real function, and you set it greater than or equal to 0 and factor and do that work. That's not the same thing as simplification. That's finding the domain pretty much. So if I want to just simplify this, I would start by thinking, oh, how can this become a perfect square? Well, it happens to be factored into x plus 3, which is just x plus 3 quantity squared, right? So what does this really become? What's on the outside? What goes on the outside of the answer? Absolute value. Absolute value. Okay? So think about it. If you square root x squared, it's just absolute value of x. That's the answer. So if you square root the quantity x plus 3 squared, it's just the quantity x plus 3 inside absolute value. Try it with numbers, you know what I mean? Like 3 squared, square rooted, get you back to 3. Right?
I just did the other way.
That I was talking about? Yeah. The directions for a problem like that, Nick, would state, determine the values of x so that the radicand is a real number. Or so that, it would be phrased differently later in this year when we get to functions. And I'll say, determine the domain of x so that the graph is, or where the graph is shown. We're pretty much asking you to find the values of x that allow for this graph to exist. Very different than just simplify. Okay, when you see simplify with a radical, just think about break it down further. Clark.
How do you know when you need to get rid of an answer to a problem like it's extraneous?
You got to check it in the original. So if you get, like, you're talking about the radical equations, right? Yeah. If you get 2 answers, you need to take both of those answers, check them not in your work, but in the original statement from the beginning, and you cannot manipulate that original statement. So if my problem were like root x plus 2 equals 3 plus x, something like that. Now, I'll make it even, on your test, I made it similar to this, but I did this instead. I put like the minus x over here, something like that. So when you see a problem like this, you got to think right away, isolate the radical, just like we isolated the absolute value symbols. So to isolate the radical, I'm going to add x to both sides. This leaves me with root x plus 2 on the left equals 3 plus x. I would FOIL on the right side because I have a binomial that I'm squaring. The left side is simply x plus 2. The right side becomes first is 9, outer is 3x, inner is 3x, and last is x squared. Very good. X squared plus 6x plus 9 equals x plus 2. I get a 0 over here. And then I'd have to factor this. Now, Clark, I don't think this is factored by looking at it. It's not. But you could use quadratic formula once we get to that topic and start talking about it more. But let's say we're factoring. You would get 2 answers from this. The key to remember, Clark, is that you've got to sub it in up here at the top. It's got to go in the original. It can't be subbed in somewhere else along the way. Okay? Then that'll give you an extraneous answer. If it says, like, once you sub in the answer, if it says 7 equals 5, you roll it out. Because 7 doesn't equal 5. Anytime you have a contradictory statement, you always reject the solution. Only when they're the same you keep it. Good question. Because a lot of people didn't get that right on the test. I'm glad you asked that question. What else? Think back, look back at notes, maybe look back at tests while you're waiting. What other kind of questions do we want to go over? Yeah, Jim.
I have one from the supplemental exam that was on your document.
Yeah.
Just one second, let me just open it up.
You saw that also, right? I put an extra set of questions there. It was like an old exam I gave when, I think we had like a snow day, so I gave them like a supplemental take-home part for an exam or something like that. You got it, Jim.
Okay. It was number 18 I have some trouble with.
Okay.
With especially part B, the formula.
Can you read it real quick?
Yeah, so it's a multiple part. So at 9 a.m., the empty storage tank started filling up with the fluid at a constant rate. At 11:30 a.m., there were 1,200 gallons in the tank.
Time 11:30.
Yeah, 11:30.
At 11:30 there were how many? 1,200.
Yeah.
Okay.
And so then it would be I understood how to do the coordinates, but I had trouble with writing the functions.
All right. So this is a good problem. Definitely a midterm type problem where you have a function where you're given a word problem and a scenario. And part A is identify the coordinates that you have from this. So this is the hardest part of this problem is recognizing that the beginning of the problem should be time equals 0. Time equals 0. Now, how much time, has elapsed from here to here? 2.5 hours. That's all it is. So as a result, I don't need to list these times. It's like 9 and then 11.5. I wouldn't list it that way because what happens when you get to 2:30 p.m.? Follow me? If you list 2:30 p.m. as 2.5 and you list 9 a.m. as 9, that doesn't make sense mathematically to go from 9 as a time to 2.5 as a time. That would be like a decrease in time. So if you're going to use your times, you got to do it with military numbers. So if you want to think about 2:30 p.m., that's 14:30. So 14.5 would be the number. So I don't like to do that. I don't like to deal with that. So you call your starting time equals 0. So if 9 a.m. is time equals 0, then 11:30 a.m. is time equals 2.5. And the idea behind it is I'm just looking at the gap in the time that has occurred, or elapsed, I should say. So that allows me to make these coordinates a lot simpler than having to deal with the actual times themselves of 9 a.m. and 11:30 a.m. So therefore, if it starts filling at 9 a.m., how much did it have in the tank at 9 a.m.? Nick? 0. So at 9 a.m., it's got no fluid in it. That's my first coordinate. At 11:30 a.m., which is after 2.5 hours have elapsed, it's got 1,200 gallons in it. So my two coordinates are these two to start. Now, for this particular problem, had you used 9 and 11.5, it would still work, actually. It really would still work. But then your answer later on, you're going to get for when is the tank empty, might be like 16.5. Then you got to figure out that's 4:30 p.m. Okay, I got to write that as an answer. So it just makes sense to call your starting time 0. And you're going to see this in physics in 2 years. So I'm highly recommending that you take this advice because it makes life a lot easier for you. Part B says write a linear function that describes this. So to write a linear function, what do I need?
Either 2 points or a slope and 1 point.
Very good. I need a slope and a point or 2 points. Either of those things. Now, you could give me an answer for a linear function in 3 ways here. You can make it standard form, ax plus by equals c. You can make it point slope form, y minus y1 equals m times x minus x1 times the quantity x minus x1. Or you could use y equals mx plus b. For the most part, for all word problems, use y equals mx plus b. It is the most direct. The b value is your starting value. The m is your slope. It makes it much easier. What amount of fluid did this problem start with? Physically, how much fluid did it start with?
0.
0. So what's your b value automatically going to be? Yeah, your y-intercept is definitely going to be 0. So when I think about this, I think about this as a volume as a function of time. Okay? T is x, same thing. T is x. Neighbor.
I have a question from the test.
Give me 1 sec. Let me just go through this last piece here, and then no, that's all right. And then I will go to it. So when I want to continue this next part, I look and I ask myself, what's my slope? My change in y is 1200. My change in x is 2.5. I want 1200 over 2.5. That'll give me the slope. I don't even need these because they're both zeros in this case. So 1200 over 2.5. 480. Thank you. So 480 gallons are gained every what?
30 minutes?
No.
Or
Hour. My units are hours, so every hour. And again, the b value is the starting point. B value is the starting point. I can find it by plugging in one of my coordinates. But take a look. Hey, plug in 0 for x and y. 0 equals 0 plus b. What must b equal? 0 also. And that is just validated because you started off this problem where the tank was empty. You started the problem where the tank was empty. 2.5 hours later, the tank had 1,200 gallons in it. So I don't really need to actually plug in a coordinate to find the y-intercept here. But if I were confused or forgot, I would plug in one of my two coordinates, and it would give me that b equals 0. So here's my volume function itself right here. Jim, before I go on to the next parts, let me just see what the other parts were for this problem.
Yeah.
I want to see if it's worthwhile to go over it now or to just let you guys finish. So that was part B. Okay, it said discuss the significance of your slope and y-intercept. Your slope is? What is it? But what is the significance of it, Sean?
Oh, the significance is that's how fast the tank fills per hour.
Very good. That's how many gallons the tank gains per hour. 480 gallons per hour. And what about the y-intercept? We just said its significance is the starting value of the tank. It started empty, so the y-intercept is 0 in this case. Part C says how many gallons will be in the tank at 4:30 p.m. This is where it would be very useful to do what we did earlier. If you go ahead and use 4:30 p.m. and you plug in 4.5 as 4:30, it's not going to make sense here. Okay, 4.5 is not the time, but 4.5 would be the duration. So from when it started at 9 a.m. to 4:30 p.m., how much time has elapsed?
7 hours and 30 minutes.
7.5 hours. We need to be able to do this kind of math in our head. 9 a.m. to noon is 3 hours. Noon to 4:30 is 4.5. 3 hours and 4.5 hours is 7.5 hours. So part C says find out how much is in the tank at 4:30 p.m. So we're evaluating the volume function after 7.5 hours have occurred. And that'll give me some quantity. You got that number from you, Nick? Petralia? You had the other one earlier. You got C also or no?
No.
Somebody give me 7.5 times 480. What do you got? What do you got? What do you got? We're doing the volume. 3,600. Thanks, slow. So that's how much is in the tank. Why does that answer at least make sense? It's got to be what? More than this number that we have as a rate or a starting value, which is 0 as a starting value. In 1 hour, you would gain 480. In 2 hours, you would gain 960. So you recognize that it's proportional, obviously. Part D said in this problem, when will the tank have 2,600 gallons? Gallons, gallons, gallons. What variable is represented when I hear gallons? Yeah, the volume, the y variable in this case. Remember, this is time and this is gallons. So time in hours and volume in gallons. So 0 hours, 0 gallons. 2.5 hours later, 1,200 gallons. So if we want to know when, meaning at what time, at what time will there be 2,600 gallons? So we replace V of t, the volume, with 2,600, and then we solve that for time. And remember, this time as an answer is going to be the time it is after 9 a.m. The time we get as an answer is how much time has elapsed after 9 a.m. It's not the answer we're going to give. It's not the answer we're going to give because it says at what time in this problem. I think it says at what time. What do we, yeah?
It does.
What do we get for a number? Because I want to actually emphasize this. So what do we actually get here for t? What does 2,600 over 480 give us?
5.41.
So is 5.41 an actual time in the day? No. It's how much time has elapsed since the problem started. So if it's 9 a.m. when we start, and just say 5 hours, forget the 0.41 right now. It's 9 a.m., we know 5 hours have elapsed, so we're already at 2 p.m. Right? 3 hours is noon, 2 more hours is 2 p.m. So I know I'm at 2 p.m. already from this. 4/10 converted to minutes. How would I do that?
4 times 60.
What are we going to get from that?
Oh, that is 24.
4/10, he's saying, of 60. Remember, what is this saying? 5 hours and 4/10 of an hour. Well, what's 4/10 of an hour? Do 4/10 times 60, because 60 minutes is an hour. So you can find out the exact minute. So you said 24, right? 4/10 of 60 gives us 24. So this is at 3, oops. Let's move it up. This is 5 hours and 24 minutes, which is now 3:24 p.m.
Oh, can we round the 1 away?
Yeah, I mean, because honestly there, what are you going to do? You're going to give me the next second, right? So most likely if I give you a problem with time, it'll come out to be like at least to the nearest minute, you know? You're not going to give seconds there. Okay, but that's the general idea. Convert this and think of 0.41 times 60, you'll get around 24 minutes. And that'll go there. Andrew, you had the next question, I think, right?
Yeah, it's in parentheses x plus 2. And
Okay.
then times in parentheses x minus 2 equals 3x. And then
Yeah,
determine-
solve.
Yeah.
So this problem was a common mistake on the last test and the test before that because of the fact that we have to recognize that 3x is not a factor. A lot of you interpreted 3x as one of the 3 factors here. There are only 2 factors here. The 2 factors are on the left side. I can't solve an equation that's factored unless it's equal to 0. So I have to move the 3x over, and the only way I can move it over is by subtracting it. Because to get 0 on one side, I've got to take away everything that's on that side. So I need to start by subtracting 3x from both sides. Now, the common mistake I'm mentioning here is that people multiply this instead. They put a times symbol here. At this point, I no longer have factors now. Right? These are factors of each other, sure, but they're not factors for the entire equation because these are different terms. I talk about this a lot. Whenever there's a plus or a minus sign, you have terms on each side. These are terms. We can't solve this because they're terms. So I need to multiply this out. It happens to be difference of squares. It's very nice. We get x plus 2x squared plus 2x minus 2x. Those cancel. And then minus 4 minus 3x. And then just reorder it. And then you can factor. Can you solve from there? Good? Does that make sense?
Yeah.
Okay? So for all of these problems, when you're going to solve by factoring, you gotta have 0 on one side. Okay, you gotta have 0 on one side. That's where the 3x moves over to start. And you can go ahead and check them both in the original. But for the most part, just a heads up, these problems with factoring, with just starting with quadratics, they're never going to have a rejected solution. You're not going to have a rejected solution. It's the square root problems that turn into quadratics where the rejected solution occurs a lot. Right? Remember the square root problem where you have the square root and you have to square both sides? Sometimes those turn into quadratics by nature because you have to FOIL one side. Good chance that one of those two answers will not work. Real good chance. Because the problem started as a square root. It didn't start as a quadratic. That's the reason why. Gus?
Okay.
Yep.
On page 329 in the textbook, it is number 15. 12x cubed y over the quantity 4xy squared. That's it, and then that's squared.
Good wording, Gus. Good wording. I was able to write exactly what you had. So, I look at this problem personally, and I start by saying to myself, unfortunately, I'd love to cancel 12 and 4, but I can't do it because 4 is not really by itself, right? 4 is being squared. And this x down here is being squared. And this y squared is being squared. So in this circumstance, I would automatically square the denominator parts first. I would distribute. Remember I used that word distribute a little bit loosely here? I would kind of distribute the squared to everything in the denominator. So I'd leave the numerator alone. The denominator would become 16 x squared y to the 4th. And where do I get that? What is the exponent of x? It's really a 1. This is really a 1 here. And when I raise a power to a power, what do I do to those powers? You multiply them. Now, it's very misleading because 2 plus 2 is also 4 in this case. I can see that. But you multiply in this case. 1 times 2 is 2. 4 to the 1 to the 2 is 4 to the 2, which is 16. See how I'm still multiplying those actually? There's really a 1 here. And that 1 multiplies by that 2, which makes it 4 over 2, which is 16. Then I simplify after that. My 12 and my 16 are both have 4 go into them. So that becomes a 3. That becomes a 4. X cubed over x squared. I think of having 3 x's up top and 2 down below. These 2 down below cancel with 2 from up top, leaving me an x up top. That's gone. And then the y part, I don't like to use the negative exponent, all those rules I mentioned, I kept saying that. I think of this as y 4 times. And I think of this as y once. And this 1y up here cancels with one of these, leaving 3 down below. So what am I left with? 3x over 4y cubed. Okay, look at what I'm left with. I'm left with this 3 here. This x is left behind, nothing else is there. This y was canceled, so just 3x. And then the bottom I have the 4. These x's canceled with these 2. One of these y's canceled, leaving me with 3 from the bottom. That's y cubed. Yeah? Questions on this type of problem? Definitely laws of exponents will show up. 100% will show up. And you got to be able to do them and do them efficiently because if they're multiple choice and you make a simple mistake, then you're not going to have any options there, right?
Will there be questions on like properties,
Like additive property of equality and stuff? I don't think we included them. I'll tell you right now. I don't think we included them this year.
Yeah, I think we should. Yeah.
I can tell you. Hold on. Give me 1 second. Because Mr. Hall and I don't usually go into big detail with that because you do that in your geometry course next year. Just wait. Just FYI. I love the geometry course and I used to teach geometry and I love the class and it's awesome. But you definitely do a lot with reasoning and proofs and stuff, which is why we kind of introduce it in this class. But I don't think we include it as a midterm topic. Let's see. One problem, okay? On the whole test is one problem for properties. That's the only thing. I mean, if you know how to simplify from step A to step B, and you know that you just move something over by adding, additive property of equality. If you changed it by multiplication by the reciprocal, multiplicative property of the inverse, or reciprocal, or property of opposites. If you want to practice it, we can do a couple of those. You want to do one of those together? Yeah? Can we, just because I'm not going to make them all up, let me look at a textbook real quick and see what we got.
So none of the ones that are like, there are like 5 lines and you have to name each one to get.
I'll give you an example of something comparable to what you would see on the test. Hold on. This is in chapter 2, was it, or 1?
Chapter 1.
Where in chapter 1 now?
I think we did a quiz on it.
Okay, here we go, yeah. All right, so something like this. This is page 18, number 20. This is just a random one I'm pulling out of here, okay? So it says 3 plus 4 times the quantity x plus 1 equals 3 plus, and then it says 4x plus 4 times 1. And then after that, it just continues down each step. So let me show you what I mean by this one. 4x plus 4. Next one becomes 4x plus 4 plus 3. The next one becomes 4x plus 4 plus 3. And then the final line is 4x plus 7. And it says to give a reason for each of these. So if I look at the first one, what's physically happening in the first line alone? Just look from here to here, I'm saying. From here to here, what is physically happening?
Distribution.
You're distributing. So therefore, it's the distribution or distributive property of equality. Actually, this is just distributive property, not of equality. Just distributive property. Second part. Now, how do we look at this? Follow where I'm pointing, because a lot of you confuse this and you put your answers in like the wrong line. We now look from here to here to put that answer here. And then the next one, you go from here to here, it goes there. From here to here, it goes there. From here to here, it goes there. So from line 1 to line 2, what has happened and what property are we using to let that happen, Sean?
Identity property of multiplication, you multiply 4 by 1.
You multiply 4 by 1, which is identical to what it was to start, hence identity property of multiplication. What's the identity property of addition? Or when does that occur?
When you add a number by 0.
Yeah, when you add 0 to something. That's the identity property of addition. The identity property of multiplication simply means what do you multiply to get the same number? You multiply by 1. Now, from this line to this line, don't give me the answer. Tell me what's happened. Not the answer, but what has happened.
You flip them.
Okay, so you switch the order. Take a look. From here to here, we've just switched the order of addition. When you switch directions, I told you guys to think about going to school and back. You come to school, you switch directions, you go home. You might say that you're commuting to school, right? Commutative property of addition. And there could be commutative property of addition or commutative property of multiplication. If I do 4 times 3 or 3 times 4, it's the same thing. Again, don't give me the answer, but tell me what's happening from here to here. Not the answer, but what's happening from here to here. I'm changing the way it's been. What's the word for this? But what am I changing the way it's been? Grouped. Who is your friend of groups? Who is your group of friends? Oh, that's loud. Sorry, guys. Who is your group of friends? You think of who do you associate with. Remember I was trying to give you guys mnemonics to remember? So the grouping is what changed here to here. So this has to do with grouping. It's the associative property of addition. And then finally, the last line, 4 plus 3 equals 7, right? So what have we done here? It's not the additive property of equality. It's very tempting to say additive because you're adding. That's when you move things around the equation. What have I done? I replaced 4 plus 3 with 7. So what principle? It's a principle, actually.
Substitution.
Substitution principle. Okay? So if I were you, I would look at pages 18 and 19 for practice, if you want to do those for practice, okay? 2 good pages to practice those types of problems. Do I see you guys tomorrow? Do you want?
No.
Okay. I do have office hours tomorrow for school. Don't forget, because I'm not going to see you, so make sure that tomorrow, if you want to come by, don't forget that I'm here. And then Thursday, we'll review again before the midterm. Okay? Have a good day, guys. Recording. So, I'm looking at, just so you know, page 200, 201. Those 2 pages where everything is with height functions. Let me try to find a harder one. I think we've done this already, unfortunately. Here, let's do this one, okay. We did that kind of yesterday. All right, so page 201. Page 201, number 19. Let me know if this seems really familiar, because I think it might have been a problem set question. It says, a rocket is moving vertically upward with a speed of 245 meters per second when its fuel runs out. How much further will the rocket travel with no fuel based on its push before it starts to fall back to the ground? Did we do this one? Does this seem... No? Okay, perfect. So when I think of this problem, here's what I think of. I think of the rocket here, and the rocket is traveling upward. And the reason it's traveling upward to start is because it has fuel, right? The fuel propels it forward by burning fuel, and a thrust force pushing down pushes it upward. Now, at some point in time, though, this rocket, now it's traveling with a constant velocity right now. It's traveling with a constant velocity of 245 meters per second. And at some point in time, a little bit further up, the fuel runs out. The fuel runs out. And at that moment, this is the velocity still, because this is a constant. That's that little bar means constant, by the way. This is a constant velocity. So the whole time it's traveling, it's 245 meters per second the entire way. So this is what it looks like. And then the fuel runs out, keeps going, keeps going, keeps going, stops, and then starts to fall back down. Okay? So how would I visualize or picture this kind of a problem?
Wait, did it fall vertically down, or does it like arc and then fall and then?
We assume it falls vertically down. We assume it's one-dimensional for all of these problems. They're all height functions. In physics, you'll do two-dimensional, but you assume one-dimensional. How do I think of this problem? Because we haven't done something like this, right? We've looked at problems where an object is launched with an initial velocity, and we say, how far does it go? We haven't done any problems with this fuel involved. It's been like you launch a bullet or a ball, you throw a baseball up in the air. As soon as you let go of that baseball, there's no fuel propelling it upward. It's just gravity that's slowing it down. So when the fuel runs out, it's going to be moving. So that's like the beginning of the problem when the fuel runs out. So it's traveling, it's traveling, it's traveling, and at this moment right here, the fuel runs out. And when that happens, the velocity is still 245. But what's going to happen when the fuel runs out? It's going to eventually slow down and then stop. So when I think about this is like my initial velocity at this moment. This is the velocity of 245 because, as Clark just said, yeah, it's going to continue upward without any fuel, but eventually it's going to stop here and then fall back down. And I'm trying not to draw the arc, but it's hard to draw on top of stuff, right? So we assume this object, again, runs out of fuel at some point, and that's like where it's launched from, if you think about it that way. Because if I think about throwing a baseball, there's no fuel ever. It's my initial velocity I give it that allows it to reach a certain height. Well, the fuel that it had gave it this velocity. But when the fuel ran out, it still had that velocity, which is we consider the beginning of the problem right here. And then the end of the problem is up at the top. So the diagram for this is probably the hardest thing, but this is the beginning. And this is the end. Okay? That's where our problem really takes place. So it's a difficult problem because of that. Now, I will tell you now, I'm not going to have something as wordy as that, but I need you to understand physically how it works, right? So if we want to know how far this rocket will go before it stops, What are we trying to figure out? How do we approach this kind of a setup? How do we approach this kind of a setup? What are you thinking? Right? It says again, it's moving with the speed of 245 when the fuel runs out. How much further will it travel upward before it starts to fall back to the ground? What are we thinking for this? Yeah, Sean. Yeah.
Minus x because 245. Well, there's like v1 equals 245 minus x because as it keeps going upwards, it progressively loses speed.
All right, so the idea is right. We're not going to be using x as a variable, but yes, the concept of losing speed along the way.
I was just going to say how we would start it, like with the equation and then like plugging in.
We could start with the equation and see, yeah. So the equation we have is h of t equals negative 4.9 t squared plus v0t. We're told in this problem that the initial velocity is 245. Now, this is the problem. This is the issue we're going to have here. How are we going to figure out when it gets all the way up to the top? See what I'm saying? There's a way to do it. I'm trying to see if anybody can pick up on it. It's not direct. It's an indirect way of getting it. To get to figure out how much the height is here, what do I really need? Start with that. Work your way backwards. What do I need to know about this point to know what the height is at this point? What other information do I need?
How much fuel the rocket has?
Joe, sorry. What was I doing?
You need to know how far initially went before slowing down.
Actually, we don't. That's a good point. We don't need this height, it turns out. We can add this height on, but the question said how much further will it go? So the measurement is here that we're starting at. But I like what you're saying because you're thinking about this height also.
Do we need the time?
We need the time. The time is the key. Because if I know the time it takes from here to here, I just plug the time into the function and it gives me the height. Does everybody see that? The height is a function of time. So I need time. But do I have time? No. But what do we know about these problems? And I don't know if we've discussed this in this class yet.
If the time's not given, can you just create a time?
No. I get what you're saying. Would you just pick a time? I get the idea. But no, in this case, it's not given, but we can find it out. So I don't think we've really got into this, so I'm going to just give you a little hint. When an object is launched and we assume only gravity is acting on it, only gravity, not air resistance, we're assuming obviously that we're in a vacuum right now. Have you ever seen a video of that in physics where they drop a feather in a textbook and they fall at the exact same rate? Literally, they would fall at the exact same rate if there wasn't air resistance, right? Air resistance. You feel air resistance all the time. So this projectile, if it takes 10 seconds to get to the top without air resistance, it will also take 10 to get to the bottom. There's symmetry involved in these problems. And I need the time it takes to get to the top, but I can't get it.
Times it by 1/2.
So find the time it takes to do this and multiply it by 1/2. Think about that for a second. If I know that the rocket takes 20 seconds to go up and back, how long does it take to go up? 10 seconds. So if I start here, ready? Follow my hand. I go up to the top. I come back around and end here. What's my overall change in height? Remember, h of t is the change in height. If I start here and I end here, what's my change? 0. So again, if I were to jump and land in the same spot I started off, my vertical displacement is actually 0. And this was something I was talking about, I think, after school the other day, or a couple of you guys were here about this problem. So the idea is that I can find the time it takes to not only just do that, but come back to here. And once I get the time it takes to loop back around, I cut that in half and plug it into the function. Well, how do I find the time that takes? Again, this is the 0 meter height. So we start at 0 meters, we end at 0 meters, so the overall height change is 0 meters. So we need to find the time it takes for that first. And again, that will be the time total. The total time it takes to literally go up from where the fuel ran out and back. Up and back, right? Up and back. So how do I find that? I find that by factoring, right? So again, I'm going up like this and back around. That's the time we're finding, and then we'll cut that in half. So let's factor out our negative 4.9 I'm pretty sure that all of these problems are factorable because we haven't gone into the quadratic formula yet. So keep that in mind. Can somebody with a calculator just divide 245 divided by 4.9?
It's 50.
50? Thank you. That makes sense, actually, yeah. Nice mental math there, Sean. So when I do factor that out, I can also factor a t out of both terms. Everybody see that a t is in both? So let me put that in front with the 4.9 there. And then I'll get rid of the t squared part, just make that a t. And this is what it becomes when I factor it then. Right? Greatest common factor. By the way, I'm telling you now, if you forget about greatest common factor, you're going to run into a lot of problems. You've got to always remember to take on the GCF, because then it makes the problem easier for you to factor. Especially like those cubic ones that are actually quadratic, because they have x and everything. You take the x out and the cubic becomes quadratic, and then you can easily factor it. So keep GCF in your mind. The GCF is 4.9 and the t, we'll do negative there. So what does my time turn out to be if I solve this? I just get 50. What does this time turn out to be?
0.
Why does 0 make sense also?
Because 0 just starts somewhere.
At time equals 0, where are you? Right there. And at time equals 50 seconds, where are you? Right there. So you have two answers that both make sense. Now, we want the time to max height, which is now going to be what? 25. Okay, so again, the answers that I get for this are the time it takes to do the entire loop and back around. So we're going to use the time to max height, which is indeed 25. So to get that, I think of T max is equal to T total divided by 2. And that was 50 divided by 2, or 25 seconds to get to the max height. But we're not trying to find the time it takes to get the max height. We're trying to find the max height itself. So we take that time of 25 seconds and do what with it? And do what with it?
You put it into the equation.
Good.
25.
Plug it in there and there. In reality, what are we doing? We're evaluating h of 25. H of 25, not times 25, h of 25. So we're taking the height function and we're plugging in 25 wherever we see a t. Remember that evaluating a function with parentheses is not multiplying h times 25 there. So the 25 goes in here and it goes in here. So whenever I do f of 2, f of 7, I plug 7 in wherever x is. So this is h of 25, plug 25 in wherever t was given. And then we get a value for that. We can calculate it. Anybody have a number we can write down real quick if you have it? What do you got?
Negative 4.9 times 25 is negative 3,062.5.
Okay.
And
245
times 25 is 61.25.
It is squared. Sorry, it's squared. Go back and change that one. I apologize. It's squared.
Yeah,
You squared it?
I factored for the square.
Nice. And the other one is 61.25?
Yes.
Okay. So as a result, we're going to get positive 3062.5. Right? That should be half exactly, I think. I think that number's right. Should be half the value itself. So for these problems, we want to consider the fact that symmetry exists. The time it takes to get to the top is the time it takes to get to the bottom. Okay, so that would be the height that it continues to go above from where the fuel ran out. Now, again, a complicated problem because it had to do with fuel running out. So, if it were me and I were practicing this, I would probably look at like numbers 15 and 16. Those are more reasonable for the midterm, okay? I wanted to just do a little bit of a difficult one so you guys can see the idea of where you'd be headed. But 15 and 16 pretty much just don't have this beginning part of the problem. Like this right here, guys, that I'm pointing to. It just doesn't involve fuel running out. It's like it starts at the ground, it's fired, how far up will it go? Or it's fired, how long will it take to get back down to the ground? Which is really the same problem we just did, but we only looked at this part of the problem. We didn't deal with the fuel running out because it's not part of the problem itself. Okay? What other questions? And let's try to stick with word problems because I feel like, your midterm's going to have a lot of word problems on it. We know that it's going to. You're going to have the area problems for sure, where the area of shape changes. You're going to have the word problems with systems of equations. Remember, there's the coin problem, or I gave on the test, it was like I sent cards to Italy for Christmas in America, those questions, where you have systems themselves. So there will definitely be a good amount of word problems. So let's stick to those types. Yeah.
Can we go over a free matrix word problem?
Yeah. Sure. So setting it up, getting to the point of a matrix, and then plugging it in real quick? Okay. So we're looking at section, I think it's 3.5 or 3.6, 3.6, sorry. So I'm in section 3.6 right now. Let me pick a problem. This is page 133 that I'm looking at.
What lesson is this?
This is lesson 3.6. Lesson 3.6, systems of equations but problem solving. I'm going to look at number 10. I'm picking this problem on purpose because you could solve it by hand, but I want you to be able to practice a matrix. Now, if the problem has 3 variables in it and 3 equations, you should absolutely use a matrix. You should not spend time solving that on the test because it will take you 5 or 10 minutes just to get through the process, and there's a lot of room for error. So you set up the problem, you set up the equations, you write the matrix, physically write it out for me, do it in your calculator, and then go right to the answer. Okay, no need to do it by hand. This one is 2 variables, so we can do it by hand and the matrix to check. A caterer's total cost for a catering party includes a fixed cost, which is the same for every party. In addition to the fixed costs, the caterer charges a certain amount of money for each guest. It costs $300 to serve 25 guests and $420 to serve 40 guests. Find the fixed cost and the cost per guest. Now, before we begin the problem, I need you to think about modeling equations. Fixed cost, cost per guest, linear functions. What do they represent in linear functions? The fixed cost and the cost per guest. Either one of them. B is the fixed cost. Your y-intercept is the starting value. If I order from this caterer, it's $100 just to have him show up. And then the cost per guest acts as my slope. And every time I hear per item, per minute, per gallon, per whatever, it's slope. Right? We picked up on that by now? Slopes are rates of change. So this is the cost per guest. So M is the slope, and that's the cost per guest. And B is the y-intercept, and that's the fixed cost that you have to pay the caterer just to show up. So we have the model of this. Right? There's our model right there. And we're told 2 scenarios. So I should probably use those 2 scenarios. I'm told the following, and I should actually do this. Ready? I should list what things are. Y is the cost. And X is? What's X? Number of guests. Number of guests. So in this case, I'm given those values. I'm told it's $300 for 25 guests. Well, does that help me? Is that enough information to solve this problem? Can I get M and B right now? Can anybody give me M and B right now without any information? Unfortunately, you can't, because how many variables are there?
2.
And how many equations right now?
1.
So what do I need?
2 equations.
Another, so therefore I need another what? Scenario, equation, I like the word scenario, it's a word problem. I need another scenario, and it's given, right? We're told that, you know what? It's $420 to cover 40 guests. And now I've got a system of equations. With the system of equations, I can solve this, and now, John, just for FYI, I would not use a matrix here. We'll do it to practice. The reason I would not use a matrix, look at your B values. They're perfectly even, right? So multiply this bottom equation by?
I was thinking you would do delta y over delta x.
That's fine too. You could do that. But what I'm saying, what do you see when you just multiply this by?
-1.
Yeah, multiply this bottom equation by -1 and then use elimination. You can use substitution also, right? Substitution works here because you can easily isolate B in both equations and then plug in. That's fine. But I would personally just multiply the second equation by -1 or just subtract the second equation from the first equation. But I would not solve this with a matrix, but I'm going to show it anyway. So let's multiply the second equation by -1. And then I'm going to rewrite the first equation above, right below it. The first equation was 300. And I'm going to write it with my coefficients properly written. Okay, so remember this is equation 1, that was equation 2. This is equation 2 that's been altered a little bit. This is still equation 1. And we're going to sum those together. Okay, so this black line here is not a sum line. Okay? The black line is showing that I've changed the equation a little bit. So again, multiply the second one by -1. That's why I call it equation 2a. It's been altered a little bit. And then I take the original equation, carry it down, add straight down. Okay, we'll get -15m equals -120. Is that 8?
Mm-hmm.
M is 8. So the cost per guest is $8. Oh my God, that's amazing. $8, that's really cheap. $8 per guest, that's amazing. So that's what the cost per guest is. An old book. It's written in like, I think the 70s or 80s when this was actually published. What else do I need? I need the fixed cost. So how do I get the fixed cost? What do I do with the m value of 8, Bridget? Where, Bridget? Yeah, which one? What's the answer to which one? Does it matter? Good. Doesn't matter, right? It does not matter. You pick the equation that you think works better. Either of these two, as Bridget said, works. Either one. I'll plug the 8 in real quick to this one, because 8 times 25, I can do it in my head, it makes 200. It means the fixed cost is 100. It just makes sense to plug it into equation 1. So plug that back into equation 1. Right? And you get that the fixed cost, the B value, turns out to be $100. So $100 for the caterer to show up, $8 per head, per person.
When would you know when to use a y equals mx plus b?
Whenever it's something that has to do with a cost per item or gallons per mile, when you see something to do with slope, you're probably going to want to use y equals mx plus b. Now, in other cases, though, it's different. Like the coin problems are different. There's no slope there, right? It's like 0.25 times the number of quarters plus 0.1 times the number of dimes, because that's their rate, that's their value. It's the same idea here. Now, if I wanted to solve this with a matrix, because I know people like to do that, I'm going to take these two equations here and write them as a matrix on the left. I would write the following. I would reorder it in my mind as 25m plus b equals 300. In my mind, I would be doing this, not writing it. It's a waste of time to write it. 40m plus b equals $420. Now, the matrix from that is simply the coefficients. Okay? I then take my calculator. Do you remember how to go to the calculator?
I think so, yeah.
This is a 2 by 3 matrix. 2 rows, 3 columns. 2 rows, 3 columns. So if you go into matrix, press second matrix, go to edit. You want to edit the matrix, remember. So second math on your calculator. Go over to edit. Make your matrix 2 by 3. Input these values. Perform the operation RREF on it. And you should get the following matrix as a result. That's what you'll get out if you perform the operation correctly. If you're struggling with performing the matrix, I don't want to get time right now to do that on the board. I can help you individually if you want to. Come by after school today. I'll be after school for like an hour today. I have robotics normally, but we're not having it because of midterms today. So if you want to come by today, that's fine. Or if you want to come by tomorrow after you guys all have 2-hour exams tomorrow? Is everybody at noon tomorrow?
Yeah.
10 to 12, yeah? So from like noon until 1, I'll have time if you want to come by tomorrow for any last minute questions and stuff. I won't have time next week on Monday. So if you want to do it, come by tomorrow. Is that clear what I'm saying? And then at like 1 o'clock, I have a couple older students or other students coming in to work on some science stuff. Yeah. Okay, good. Okay, people are active. Check the video on Moodle tonight. Learn how to use a matrix. If you still can't do it, come see me about it and go over it. Look.
So all we need on the test if we were to solve it, matrix is
1, 2, 3.
Okay.
Just like that. Show the equations, show the matrix you input, show the matrix as the output, and then just. But personally, though, I don't just do this on
Yeah,
my
that by hand,
because
but
it's
like
2
you
by
have
3.
3 variables.
Yep.
Where do you find the
It's in the matrix command. So go second matrix. So go back to the home screen. You gotta get out of the matrix. Go back to the home screen, and go back into matrix, and look for one of the commands. It's a different column. You see it?
Yeah.
Okay.
RREF?
RREF.
Yeah.
Row reduced echelon form. It's a command that allows the computer to do a lot of the work, calculator to do a lot of the work for you. You'll learn how to do that by hand with rows and matrices in college, in linear algebra. It's a really cool
I got a
course.
syntax error.
You got what?
A syntax error.
I mean, something you told you is wrong. I don't want to take too much time there right now. Try to figure it out, Sean. If not, you can ask me. All right, let's move on. We only have about 20 minutes. That was 2 questions. What other problems do we want to go over? Or what's another type of problem we want to look at today? What do you think? Yeah?
The interchange variable one.
Ooh, yeah, that's a good one. Okay. Do you remember by any chance?
I know it was number 12. I don't remember what page it was. Olivia and I were working on it yesterday in.
Section.
Section
Isn't it 2?
chapter
2
1.
I thought it was 2, 3. It's 3, 1.
3-1. And you were looking at number 12, guys? Okay. Yeah. Nice. It says, and X says, the digits of a positive integer n are interchanged to form an integer k. So the digits for integer n might be ab. And then k is therefore ba. We all see that already? What's happening here? And that's the first thing I think of. It says, find all possibilities for n under the following conditions that are described. So number 12 says, n is even, and exceeds k by more than 50. So if n is even right away, what could be? If n is even, what values can b take on? Limit your domain of choices here. 2, 4, 6, 8, or 0. Right? Yeah. Ending in 0 is even too. So b, so it says, yeah, I'll give the statement. It says n is even and exceeds k by more than 50. Okay, that's the statement itself. Now, if that's the case, first of all, before you use A's and B's and all that other stuff, let's just think about logically what this means. If n, the even part we'll get in a minute. If n exceeds k, it means k plus something is going to be n. Is everybody with me with that? Does that make sense? If Jimmy's score on his test exceeded my score by 8 points, it means I take my score and add 8 points to get to Jimmy's score. So in this case, if n exceeds k, it means that n is going to be bigger. So I know that k is going to be on this side, and I'm going to add 50 to k to get to n. And normally I would put an equal sign here. Normally. But am I going to put an equal sign here? I'll tell you.
No, you're going to put a greater than or equal to.
There it is. It exceeds it by more than 50. So actually just greater than. But yeah. Yeah. It exceeds it by more than 50. By 50 or more would be greater than or equal to. If it says more than 50, if it exceeds. No, just more than in this one. Another one says at least earlier on. This this says more than 50. Same difference, right? We're just arguing semantics right now. But it could change my answer. So n exceeds k by 50, but really by more than 50. By more than 50. Now, at this point, we have to start to think about what is n, right? What is n? Well, take a look at the problem and think about this logically. What's happening? Every time a number is in a unit spot, it just appears as a value. So if I have the number 41, it's really 1 plus 4 times 10. Take a look at that and think back to 7th grade, 5th grade, those areas of math. This is the 10 spot, this is the 1 spot, right? We get that idea? So the digit for n is really 10a plus b. Look at n. Whatever this is, if this was a 3, it would be 10 times that to give me 30. And then if this is a 5, that would just be 5. So it would be 30 plus 5. So a's value has to be multiplied by 10 and then add b to it. But for k, what are we doing? For k, what are we doing? Switching it. So the value of b is now in the 10 spot. And the value of a is in the unit spot. And this is how I solve this problem. And you're going to look and say, oh, Mr. Howe, this doesn't work. You just said if we have 2 variables, we need 2 equations, right? But go back to section 3.1. This wasn't about getting one solution. This was about getting infinitely, in some cases, many, and this would not be infinitely. But in some cases, like 3x plus 2y equals 7, it's just a line made up of infinitely many points all connected to each other, which is why there would be infinitely many solutions if this were an equal sign here. or if this didn't say anything about being even. But the fact that it's greater than, the fact that it's even, it doesn't make my answer infinitely many solutions. So at this point, this is for those who like the guess and check method. This is really just trial and error now. You make a table that is reasonable though. Again, what did we say B could only be? What kind of numbers?
2-digit integer.
Yeah. They're all going to be B though. The value of B could only be, Olivia's told us, 2, 4, 6, 8, or 0. So if I'm solving this problem right now, here's what I would do. I would go ahead and make a table over here and make a table of B values and then the corresponding A values. Because we know that B is limited already. B's values, again, can only be even. Because N must be even. So it's 0, 2, 4, 6, or 8. And that's it. B cannot take on any other values. Should I leave it like this? I should probably simplify this, right? Everybody agree? Like terms? Yeah? So let's move, I don't know, let's move A over to leave everything positive. I'll move A over by subtracting A from both sides. That makes that 9A. I'll move B over by subtracting B from both sides. That's 9B. And then the plus 50 is still there. So I would use this right here to plug B into to figure out what A should be. And actually, what could I also really just do? Can I get rid of the 9 in front of the A? Couldn't I just get rid of that 9? Because I'm going to do this how many times? How many times do I have to plug B into it here? All right, 5 times. Look at the B values. I'm going to have to plug 5 of them in. So it doesn't make sense to keep dividing by 9. Let's divide by 9 once. And the 9s cancel, and I can leave 50 over 9, or I can leave it like that. All right, so I can leave it like that, or I can write it like this. And either of those is fine. Remember, a monomial divided into a polynomial, the monomial divides into each term of the polynomial. So this is 9b over 9. 9b over 9 is just b. 50 over 9, oh bless you, it's just 50 over 9. So either of these would be fine to use, honestly. I would probably get rid of the 9 though, because it just doesn't make sense. So now you start plugging in b values, right? You plug in the 0 over here. Take a 0 and plug it in. You get 50 over 9. So A has to be greater than 50 over 9 for that one. What integers for A are greater than 50 over 9? And these integers, remember, have to be single-digit integers because A and B are single digits.
6 and above.
6 and above, why?
Because 50 over 9 is 5.
Yeah, 50 over 9 is 5 and change. I just want to make sure we're clear on that, right? When I plug a 0 into this function, so let's do it together. We get A is greater than 9 times 0 plus 50 all over 9, which means that A is greater than 50 ninths. And 50 ninths is like 4 and change right here. 5 and change here. So A has to be greater than 5 point something. So A could be 6. A could be 6. What else could A be? 7, 8, or 9. There are no restrictions to what A can be. We're not told that A is only even. We're not told that, when you switch these digits, K turns out to be odd. Well, then if that were the case, if K were odd, take a look here. If K were odd, A would have to be an odd number, wouldn't it? If that were stated. So then I would have to roll this out, and I would have to roll this one out. So as of right now, this is 1, 2, 3, 4 possible solutions for the values of N. And then I do the same thing for the next number, which is a 2. So I'm going to get a lot of possible solutions for this. So what you want to do, I don't want to spend, we're at 10 minutes right now. I want to do one more problem today. All you need to do is next take the 2 and plug it in. Next take the 4 and plug it in. And keep going through the process each time. And what's going to happen to this number? It's going to get bigger and bigger, isn't it? Which is going to give us fewer and fewer choices later on. So the next one might be only 7, 8, 9. The one after that might be 8, 9. The one after that might be 9. Okay, there'll be fewer and fewer options for B, but you just keep plugging in the B value. Keep plugging in this B value. Do it here. Then take the next B value, plug it in here, etc., etc.
How would you write the solutions?
You could put in a bracket if you want, and then just literally run them all off. So the original number for N is AB. So it would be 60, 70, 80, 90 from these first 4 right here. See that, John? And then you would keep listing them all, and you would list a lot. There might be 2 more here, 1 more here, whatever it turns out to be. Okay? Not an easy problem, but a problem that is fair game for sure. I would probably not make it this complex because you're going to have 15 3-point problems like this at the end. So one word problem is one of those problems. So having 15 of these, you're going to really spend a good amount of time on the free response on this test. Multiple choice, I really think you guys are going to kick butt on, honestly. Because I don't give you calculators on almost half, if not all multiple choice. You notice that? Whereas you're going to be able to use it. So if it involves graphing and you're on the multiple choice, use your calculator. Make it quicker. Don't graph it by hand. Don't do slope, intercept, and stuff. Just plug it right into y equals. So if you're not good with a calculator over the weekend, you need to practice some of that stuff. Just graphing lines. Parabolas, we have to graph it. That's on the finals. Don't worry about that. But we're just graphing lines, matrices, stuff like that. We're just being good at using it. Yeah.
Does the fact that that's only 2 variables mean that it can't be a 3-digit number?
It cannot be a 3-digit number. We were told that, in the beginning we were told that there were 2-digit integers. Yeah. In the directions it says the digits of a positive 2-digit integer n. That's why I called it AB. It would not be a 3-digit. It would just be way more complex. It's not impossible, but it would just take a lot more time. You know?
Yeah, I was going to say, that'd be a lot.
Yeah. You'd have 100A plus 10B plus C instead of just these 2 things. It would be A, B, and C. And you have a lot of possible answers. Okay, a lot. All right, let's do another one before we go. Let's do another one.